Okay, now it's starting.
Hello everyone and welcome to today's video. Well students, we did a bit of work yesterday on Ambiguous Case and we kind of looked through the idea of it, and I thought I'd do a video so that we've got some practical numbers to work with as well, and then we'll work out some answers down here and we'll see what's going on. So the ambiguous case is when you're given some information about a triangle, but the information you're given doesn't give you a unique triangle. There's a couple of possibilities. That's the meaning of ambiguous, a couple of possibilities to it. So I'm looking at this triangle here, and it's not really a triangle yet because I haven't drawn that side for a reason. But let's say that I've got the angle A, this one here. I've got side A, which is going to fall somewhere here, and I've got side C. So from that case there, and I'll just rub out these ones at the moment because I want to just keep the information that I do have. So that's the information I have. What sort of triangles could I draw from there? Well, because I don't know this side here, that wasn't in my given information, then that side may well be this long. I don't know where it ends. But I know A of some fixed dimension. Now, A could be straight down there. Now, if that was the case, then, and that was at 90 degrees, I wouldn't actually be in an ambiguous case. That would be a unique triangle. I might not know it at the time, but that would be unique. That's probably unlikely when we look at all the possibilities. So what's more likely is that A is some distance slightly longer than that, and we find that A might be here, whatever that distance that is, and therefore the triangle ends there. And you might think, well, okay, that's fine, or can't I work that out? What's the problem here? Well, the problem is that if we take this side here, because remember this is fixed, and this is fixed based on the information. But if we take that, can you see if I was to swing it down to straight up and down, this side would be maybe there, okay, on that pendulum swing. But if I keep going, can you see that that would swing back up there? It'd kind of, and wouldn't then this be a valid answer as well? Couldn't I have that triangle there or the bigger triangle? So I kind of end up with two solutions here. I'll sketch a small diagram of them. So I end up with a solution that looks like that, and then keeping that same information of that side, that angle, and that side where that and that are the same. These two triangles are both defined by this given information. Now the side changes, absolutely. But also the angle in here changes. So this is the ambiguous case where there's two possible angles. Now let's look at why this might happen. Well, when I take angle A and side A, that's my pair of information for the sine ratio. I've got a side as the third piece of information, and therefore I'd be working out an angle. But let's have a look in the unit circle, because the unit circle is where all this comes true. So we've got our unit circle here. We're going to measure cos on here, and sine is up on here. Let's pick a nice neat angle like 30 degrees. 30 degrees is great because I know it's going to be sine of 30 as a half, so it's an easy one to work with. Keep that one in your mind. You always want to keep sine of 30 as a half. So there's 30 degrees. So that means that when I bring this one across here, I'm going to be at a half. And my diagram's reasonably accurate. It's a sketch, so it's not too much of a problem. Now what we find is, if you remember, we did where different things are positive and negative in our unit circle. So we had that little acronym. It was all stations to Claremont. So we're meaning that they're all positive here, sine is positive here, tan is positive here, cos is positive here, and by default the other ones, sine and cos, are negative here. The other ones, tan and cos, negative here, and here it's going to be sine and tan are negative. So we've got that idea there, and you probably should see now that if I drew some angle over here, wouldn't that also give me the same sine value? And what you'll notice is that this angle is going to be exactly the same as this angle. So they're both going to be 30 degrees. Now, of course, we measure all our angles from here. So that would mean that I'm not going to measure this as 30, it's going to be 180 degrees minus 30. So what we find in this situation over here is that we've got the sine of any particular angle that would fall in the first quadrant is going to be equal to sine of 180 degrees minus that angle. Okay, and that's where we're going to see these two here. That's where we're going to see these come out. Now, another way to think about it that one of my students said yesterday was that if we've got this angle here and we work that out, yeah, we can use that, certainly, but because this triangle here is an isosceles triangle, A, and this is also going to be A, this angle here is going to be exactly the same. Let's put a number. Maybe that looks like about 50 degrees in there, let's say. Might be a little bit more, but let's go with 50. So those two are going to be 50 degrees. Now then we look at this here, and we say that's a straight angle, got to be 180 in total. So 180 minus the 50 is going to get me 130 degrees, which is kind of what we're doing here. Well, it's exactly the same, really. 180 minus the 50 will get us 130. And if we were to do those two angles on here, then they would come up to the same sine value. So that's why the ambiguous case comes about, and it's only when we have an angle, its opposing side, and another side. If we've got two angles, this doesn't come about. It's when we've got a pair of information and another side. We've got to look for the ambiguous case. Is it always going to be there? No, but you've got to check. So let's work the question through. Here we go. We've got A, 30 degrees. We've got side A as 5, and we've got C as 15. Let's work this through. I hope this one works out because I haven't pre-worked this one. So I would say, because I want to work out an angle, and I'm going to work out angle C, I'm going to put C at the top. So sine of C equals sine of A. I'm going to come up with that formula there. Let me put in my numbers, and I'm going to cheat here by using the same area rather than coming down here. Sine of C I don't know. C is going to be 15. A is going to be 30. And A here is going to be 5. Okay. Now I think I can see this might not be working out, but that's okay. We'll talk about that when we get there. Move this one up over here. I get sine of C equals 15 lots of sine of 30 degrees over 5. Now I'm sure this one's not going to work out, but that's okay. So sine of 30, remember I said we've got to remember that's a half. Half is a great one to remember for sine 30. This is why I know it's not going to work out. If I do sine of 30, that's a half. If I multiply that by 15, I get 7.5. Now then 7.5 divided by 5 is going to give me a number greater than 1, isn't it? Now on our unit circle, at least for sine and cos, the maximum is 1 and -1 for cos, 1 and -1 for sine. So this calculation here is going to come out at 1.2 or 1.5, I think it is. So it's going to be far too big. So that means that this triangle would not be able to be drawn. If you ever get the sine or the cosine of an angle being greater than 1 or less than -1, the triangle can't exist. So I'm going to cheat here a little bit. This side effectively, what it means is that side was too short to actually reach onto this one. At that particular angle, 30 degrees, too short to reach. So I'll cheat a little bit, and I'm going to turn this one into 10. Make the side longer. That would make that one 10. Make this one 10. And now let's do a calculation. We're going to have the sine of 30 degrees, that's a half, times 15, 7.5, divided by 10. When you're dividing by 10, just move the decimal place. So 7.5 becomes 0.75. So the sine of C equals 0.75. Let's look at our diagram here. That means that we're maybe about there. So if we dash a line out this way and out this way, then the angle we're looking at is going to be that one there and that one there. But to get that one, we're going to do 180 minus that. Now I'll get a calculator here and we'll do a bit of calculation real quick. What have we got? We've got 15 times the sine of 30 degrees equals, divided by 10, there's my 0.75, inverse sine answer equals, I get 48.6. 48.6. So C is equal to 48.6 degrees. Now the calculator is always going to give you the answer in the first quadrant or the first answer it's going to come across. Okay? We need to realise that's only one of the answers. based on this idea up here, I would just go 180 degrees minus that. So I'll do that on here. I'll go 180 minus the answer, and I get 131.4. Okay, 131.4 degrees. Now, to check that we've got this right, if I took the sine of 131.4 degrees, I should also come back to here, and I'll do that. Sine of the answer equals 0.75. So we're back at this number here. I know that this number, when I take the inverse sine, I can get both of these angles, meaning that if I update this diagram with all the measurements that we know, so that means that A here was going to be 10, C here was going to be 15, A here was going to be 30, and from that triangle I end up with this. So this angle in here would be 48.6, and this angle in here would be the 131.4, meaning I've got my two answers to the ambiguous case of sine. Hope this video helped.